Okay, let's talk about what's called the natural exponential function. So you've probably seen this before, but y equals e to the x, or f of x equals e to the x, is what we call the natural exponential function, and that means that our base, instead of being a number that we're used to, like 2 or 3 or something like that, is instead e. So what is e? E is a constant, kind of like pi, where we have a never-ending decimal. But its use is essential with exponentials and logarithms when we get to that. So first of all, I just want to talk about what e is. And if we look at Desmos, before I evaluate these, I plugged in just e so that you can see the constant e is about 2.7. Okay, so again, it's like pi. It would just continue on in its decimal form where we have this constant. So 2.7-ish. So if I want to evaluate these, and I'm going to ignore the 5 decimal places part of this. But if I want to evaluate these, what is e to the third power? All I'm going to do is type that in, e to the third. We got 20.09-ish here. And then 2e to the negative 0.53. Again, just plug that in. We get 1.177-ish. 1.177. So again, you could evaluate those easily with a calculator. In terms of graphing this, again, it is exponential growth because e is greater than 1. And so if we have a value, if our base value is greater than 1, then this is going to be exponential growth. And because e is like 2.7-ish, that means we're going to be going up as we go to the right. And so you see this exponential growth function here. And I highlighted a couple points on here. Again, every single exponential function will go through the 0.01 unless there's a transformation, because when I plug in 0 for my exponent, anything at all, including e, when I take it to the 0 power, is 1. And then I also highlighted this point here, which is at 1, 2.718, which this thing right here, that's e, right? So that would be 1, e. This point here would be 2, e squared, which would be somewhere close to 9, because 2.7 is close to 3. So if I square that, I'm going to get something close to 9, and so forth. So I didn't necessarily want you to think about what you had to plug those in and how you would evaluate that with e, but it's the same as anything else. You would use a calculator. You could plug in those things for x, and you get those values for their y's. But I just want you to see that e to the x is exponential growth, and this is what we call the natural exponential function.